We'll continue with the discussion of vectors, which we did last time, and this will be your last. Starting next week, we're going to get into the actual subject, actual course. Okay, you're actually required to know all of the stuff before. Now, you may want to do this with me. If we have, let's take a look at this example. So you have this vector, and if you're required to find the direction angles or direction cosine. How do you find?
Cos alpha equals e sub x.
Right. So you have cosine alpha is equal to ax over a. Right?
Yeah.
What is ax? Huh?
The function of I.
Ax is 1. Right? And your this thing is a is the magnitude of is 1 plus 16 plus 64. That is 81. Right? Square root of 81, which is. Got that? So alpha is equal to cosine inverse of 1 over. Can somebody tell me what is the cosine inverse of 1 over 9? Similarly, cosine beta is equal to ay over a, which is minus what is alpha? 83.62. What about beta? What about gamma? 27. 127. So this is how you calculate direction cosine. Is it simple? Everybody follows this?
Yeah.
Okay. Another example. We have 1, 6. If this is given, see, you can, I've given you two different representations. Get comfortable with them. You're comfortable with this, both the representations of vectors. Now, how do you find the angle between A and B? So here you can simply use cosine theta is equal to A dotted with B divided by
The magnitude.
AB.
A dot B.
So this, pay attention, this is, two vectors cannot be multiplied. The only defined operations for two vectors is a dot product and a cross product. Don't try to multiply two vectors, you can add two vectors. You can subtract two vectors. How do you add two vectors? You remember the law of parallelogram? Right. That is the law of parallelogram. So you have, if you have two vectors, you join them at the, so there is, every vector has a tail and a head, right? So you join the tail of one vector to the head of the other vector, and then join the tail and the head of the first. So if you have this vector A, and you have this vector B, what is A plus B? You have A, B, and this is your resultant vector A plus B. Okay, this is the law of parallelogram. If it is just adding these two, what are you going to do? Arithmetic, what are you going to do? You're going to add the I components, J components, and K components. So here cosine theta, this is what A dot B is. So you have 42 minus 69 into 6. How much is that? Four one four. How much is 18 into 8? 98. Huh?
1764.
7?
17.
1764 divided by AB. So you have square root of 1 plus 36 plus 18 square into square root of 42 minus 59. Got it?
So AB is the magnitude.
Right. A is a magnitude, B is a magnitude. These are just scalars. This is 1, 3, divided by This is how you find angle between A and B. Now there is very important concept here. This is the first one. Okay. Find the projection of B in the direction of A. The projection of B in the direction of A and A in the direction of B is two different things. Okay. So if you had B over here, right? So we'll just take this. You have A, and then you have, let's say, this is B, and this is A. Projection of B in the direction of A means you project B onto A. In that case, what you do is you make A as the unit vector. You understand?
You said it one more time.
You make A as the unit vector. If you want, see here it says projection of B. So B is the, you want to know the component of B in the direction of A. That time you make A as the unit vector. So you do B dotted with BA is equal to this. This is equal to so it will still be 1392 divided by this will change. Right? 19.
So that 19 is just from the 1 plus 36 part.
136.18 square. So this is the, you understand the projection? Everybody is clear on this? So when you project B on A, you have to do this. Okay? But only that component. Now for example, the projection of A on B is, you draw perpendicular to this, perpendicular to B. So what is perpendicular to B? You have this is the perpendicular, this is the component of, so this is the component of A on B. If you want the component of B on A, so let's look at the same thing. You have B, right? And then you have A. You draw a perpendicular to this. So this has to be like this. So this is the BA. Get it?
So you said the projection has to be perpendicular to the what we're looking for.
Projection of something. It's like this. If the vector of interest, what is the vector of interest here? It's B. We are looking for the projection of B. Okay? So So you're going to make you very well understand this concept, right? The projection of B on, this is the x component of B, this is the y component of B. If you, how do you get the x component? We're going to draw a perpendicular, right? And this is the bx component, right? You understand? And this is the by component. Everybody is clear with this? Here nothing much is changing. This is A. So we are interested in this component. Or you can say this is A. If this is A, this becomes BA. If this is A, this becomes B. The projection of this vector onto this. Right? It could be, so you see while we are doing this A, vector A over A, you are making this vector unit vector. So you get components of B on A. If you are asked this question, find projection of A on B. So in this case, what is this? This is your A, okay? Either this is B or this is B. Alright? I want you to pay attention to this. So you're just going to draw this and get this. So this is your AB. Sorry. This is your AB. So here, this is your AB. You get it? Confusing?
Yeah. So where's the perpendicular part this time?
This is a perpendicular. The perpendicular has to be to B. Okay, let me not confuse you. Okay, forget it. So this is B, right? This is the B direction. I am drawing perpendicular to B. I am interested in figuring out what is the component of A on B, right? So I am drawing a perpendicular to B. This is AB.
Can you point to the actual projection? Can you point to the actual projection?
We have B, we have A, right? The projection of A on B is, you draw perpendicular to B, and this component is AB.
So the part, the triangle underneath.
Right. So you just have X component and Y component, right? So what you're doing, you're just drawing the perpendicular to, you want the projection of A. So A has to be greater than both its projections, right? So what do? You project that onto whatever vector you are interested in.
So
That,
are all three of the lines of projection, or is it one line of projection?
the projection is, this is a projection. AB is called the projection.
This side of it,
Right, this side.
just this one
Right.
line.
So we are interested in what direction that projection is going.
Okay.
So that's the reason we do A B over B. So regardless of what this length is, right, this projection will always remain the same. Even if you have just this, even if your B was here, the projection length will be the same. That AB will be the same. Because you are normalizing your vector B. We are only interested in the direction. Okay? So this is AB. Alright, here is, see, I'm giving you a feel of how to use vectors. And this is what we are going to do when we actually start covering the course. Okay? So, try to understand this question. Here's another example. We have A is equal to and B find B find A. The question is, you are given two vectors. Find a unit vector that lies in the plane of AB. I mentioned to you, or we discussed last class, that any two vectors will always form a plane. So these two vectors are forming a plane. How do you find a unit vector that lies in the plane of AB and is perpendicular to A? Find a unit vector that lies in the plane of AB and is perpendicular to perpendicular to A. If you do a cross product, what are you going to get? It is not going to be in the line, it's not going to be in the plane of A. So here you have A, okay? And here you have B. If you do a cross product, your vector would be
Perpendicular to the plane. Perpendicular to the plane.
Right, it will be perpendicular to the plane, but where is A cross B? Where is A cross B? What is the direction of A cross B? Use your thumbs. Use your the right-handed system I told you.
Inside the board.
It's going inside the board, right? Because it will be A cross B. It's going inside, right? But that will not satisfy this condition. Will that satisfy this condition? It will not lie in the plane of AB. So what do you do?
That's kind of that.
Hmm?
Can you repeat the question?
If you take the cross product, right, it will be perpendicular to A, but it will not lie in the plane of AB. It will be perpendicular to the plane of AB. This is the plane of AB. This board is now the plane of AB. You realize?
So this will be like projection of D on A.
Huh?
Projection of D on A.
B on A, yeah. It can't be.
Projection of B on A will not be perpendicular to A. No, projection of B on A would be in the direction of A.
What if you take the resultant of A and B and then take the projection of the resultant?
Think on these lines. You get A cross B, right?
Mm-hmm.
This is, let's say, C. All right. What happens if you do? This is step 1. Step 2. What happens if you do A cross C? Huh? B is not necessarily perpendicular to A. B is not perpendicular. It doesn't mention there that B is perpendicular to A. And does this look like? If it looks like perpendicular, I'm sorry. So it's not. Think about this.
Yeah, so now we the same thing.
So you have this thing, right? You have your C is in this direction, your A is in this direction. So what do you need? If you do A cross C, where does A cross C lie?
This will be like
Huh?
that will be pointing towards this one.
Will it be in the plane of AB?
No, we will.
How about C cross A?
Yes.
C cross A? Will it be in the plane of AB?
Which one is A? Which one is B? Which one?
C cross A?
The C is the one on the board, C cross A.
Right. So C cross A will actually be perpendicular to A and in the plane of AB. Alright, let's demonstrate with this. Okay? These three. Everybody can see this? So this is your plane AB, right? This is your vector A and vector B. This is your vector C. Correct? So it's going from A cross B. I take this. This is not relevant anymore for me. Alright? If I use this is my new vector D. It is C cross A. Now this vector has to be perpendicular to these two vectors. Right? Plus this vector is also in the plane of AB. You get it?
Yeah, A, B is
So that is your D vector. Is it clear? Micah? Did you see that? Were you able to see that?
that is something.
D.
To shorten that up, could you say A cross B cross B? Like A cross B in parentheses and A cross B?
You can do that. You can do a triple product. So you can do A or A cross B cross with A.
Can you do the thing with the marking one more time?
So also, so this is plane AB. It's an infinite plane, so it doesn't start in this corner and go this way. It's,
An infinite plane. How do you define an infinite plane? What uniquely defines an infinite plane?
it takes 3 points to make it.
Hmm?
It takes 3 points to make it.
But you don't have those three. It's an infinite plane. How do you define it? The perpendicular to a plane always defines the plane. So if I use this perpendicular, regardless of how infinite this plane is, there cannot be two planes for this perpendicular, for this line. Can I have two planes which are perpendicular to this? This, only one plane has to be perpendicular to this. That is the infinite plane. Got it?
You
A
can't say
perpendicular defines,
you can't say like the top and bottom, or those not two different planes.
Well, I think
It is still the same plane.
Still the same plane.
It's an infinite plane. The perpendicular to that plane. So if you say this is as the origin of the perpendicular,
Okay.
this is a vector going in this direction. So this defines the infinite. A perpendicular always defines a plane. Perpendicular to a plane defines the plane uniquely. So that is what we are doing here actually. Okay. So I'll explain to you again. So these are the two vectors, right? The black marker is A and the blue marker is B. A cross B would be this. If it was this, what is A cross B?
Still the same.
It's not the same. It's
All
this.
going down.
It's this direction now because you see, it has to be like this. Okay? So this defines A cross B.
And the red one would be C, correct?
Red one would be C. So C is A cross B. Right? It cannot be B cross A. B has always to be A cross B. And if I don't need this because we are not interested in B. Now I am interested in the vector which is in the plane of AB and perpendicular to A.
So that's B.
So if I do a perpendicular, if I do a C cross A, it has to be this, right? You see, C, D, it has to be C cross A. There is nothing, there is no other direction. This is the only direction. Now this is perpendicular to A and it is in the plane of AB.
We're not on the opposite side. Opposite side.
Opposite side, this one? No, it cannot be because then it would be A cross C. You can actually do that as well. Yeah, you're right. This or that would be the same. So you can do A cross C as well. It is just another vector. The vector, the direction is different. It's a collinear vector, but the direction is different. Okay? So if you do A cross, that's the reason this is important. It's a find a unit vector. There can be many unit vectors depending on how you do it. But you understand that? It's now this is A cross C. Okay? This is how you need to use cross product and dot product, triple product. Now you have to understand there is this is really important concept wise. So this is the magnitude of velocity. Okay, this is r as a position. Are these two the same? What is the difference? Huh? This is also with respect to time. You understand this is also velocity.
Rate. That's a rate.
Oh,
Huh?
that's additional?
It's a rate.
This is also a rate.
Is that additional?
Huh?
Is that additional?
Because it's a magnitude. So it's a scalar.
Are they both with respect to time?
Both are with respect to time, yes.
So are they not the same thing?
That's the question. Are they the same thing? I'll demonstrate to you why they are not the same thing. Alright? So the way you calculate this here, you have to understand a little bit about derivative of vectors, right? Calculus of vectors. If you take a vector can change in what? Magnitude and direction. Okay? This is the magnitude of velocity. If you want to get this, how are you going to do that? You're going to first do d over dt of r. We'll do the first one. Okay. So that is what? 16t plus 7i plus 15t square. There is a j plus 1.2 t cube plus 4t cube. This is meters per second. And this is what? This is acceleration.
We take the second one.
Is this visible? Is the background too disturbing?
No.
Okay. So you see what we did? Now what is V? V is magnitude of the vector V. So this is 16t plus 7 square plus 225 e to the power of 4 plus 1.2 t cube plus 4t square. Okay? This is your V, and you're asked to figure out that V at t equal to 10 seconds. What do? You just substitute t equal to 10. So what are you going to get? You're going to get 167 square plus 225 0 0 0 0 1, 2, 0, 0. 1, 2, 4, 0. Got it? So this is your
What happened with the T?
huh?
What happened with the T?
At t equal to 10 seconds. Right? So I just substituted t equal to 10. T is here just a time variable. Okay? So this is what do you call this? Huh? What is it called? Huh? Magnitude of velocity. What is magnitude of velocity? Speed.
Oh.
So this is speed, okay? Sometimes we tend to overthink because now how do you calculate now? Can you tell me how do you calculate R? How do you go about calculating R dot?
So the given is this distance.
Huh?
The given was like displacement.
Position? Yes.
On that last parentheses, how did you get 1240? The 12.
So you have T. This would be 1, 2.
What?
This would be 1.2 into
Oh, that's what I see.
1000. Right? That is 1200. 1200 plus 4 into T is
Okay, I thought it was 12. That's fine.
it's 1.2 into T. So how do you do R? R dot? Do you do the same thing? Brandon?
I'm still on the other section, breaking down.
You're trying to figure this out?
Yeah, I need to write it all.
I just took the derivative of R.
Okay, just derivative of R.
I got V, okay? So if I take the derivative of R, see what is happening here is the magnitude and direction both are changing. Physically, if you want to make sense of this. When I take the derivative of the vector R, the magnitude and position are both changing.
Oh. So the derivative of position.
It's derivative of a position vector. Okay? Now here if I want to do this, what is this? First I need R, right? R is what? I'm going to take the magnitude first. It is square root of, it will be 800 plus 70 plus 6. 876 square plus 504 or 5004 square.
Yeah.
Oh, sorry. Actually, b 8 p square plus 7p plus 6 square 5 p cube plus 4 square. Okay. So this is what you're going to get. Is this clear? We got. Huh? I just squared all of this thing. Okay. Now, what is D? What is R dot?
It's like the magnitude
It's just d over dt of r.
So the difference between this one is this was R, that was R vector.
So here, yes. So if you look at this one, the derivative of only the magnitude is changing. It's something like this. Here, let's say you're going in a particular direction, right? You're changing your direction and you're changing your magnitude as well. So you're going this way. Got it? You're saying your position is here and you're taking your speed is, your velocity and speed, velocity is in this direction. Okay? Here you're changing both the direction and the magnitude. So let's say you're taking a right turn or a left turn. Here what is happening? You're going in a particular direction. The direction is the same. You're just speeding more or less in that direction. The direction is not changing. Huh? Here the direction is not changing. You see that?
Because there's no line there.
Huh?
There's no line under it all. Like, it's not a vector. Like this one has a, this one is a vector and this one is more like a scalar.
Both are scalars. At the end, both are scalars.
But it starts off as R vector, which has magnitude.
R vector has both magnitude and direction.
R says.
This R only has magnitude. So you're only changing in magnitude. That is, you're only changing in speed. You're not changing in direction.
Okay, that makes sense, but how do you determine? I guess it was Donald's question. He said since it's not in vector form, how do you determine like when it's supposed to be in vector form and when it's not? Because
So you look at the question, what is asked. Here, if you are asked V, you have to understand what V is. How do you say in English? How do you say this? Or in terms of dynamics, what is V? There is no vector sign there. It is the magnitude of velocity. What is this? Is there a velocity component here?
No.
There is no velocity component. Here you say magnitude of change in or derivative of change in speed or derivative of, this is speed, right? You realize this is speed? So this is what? Magnitude of position, right? If you take the magnitude of position, you think about what is derivative. Magnitude is just, see if you are here, right? So magnitude of position means this position, let's say, is just a length from this point to that point. This is just a length from this to that point. It is just a length. If the length changes as time progresses, that is this. So when you're driving or when you're taking your aircraft, you're going in the same direction. Isn't the length, the magnitude changing as time is progressing? But if you're going like this, can you use this? You don't have a sense of direction. This is, you get it?
So position and speed are the same thing?
If,
So you're saying position and speed are the same thing?
change in position and speed are the same thing.
So
Change in magnitude of position
okay.
and speed. This is also speed, but here we're taking the magnitude of velocity. Magnitude of velocity is also speed. But magnitude change in this can also be speed, but the direction is not changing. Here direction is not changing. Here direction is changing.
Okay. I
Do you get it? No?
I understand how the direction changes.
So you see, what is this? That is velocity. So what does velocity mean?
Velocity is speed.
Huh? Velocity is not speed.
Direction.
Right. If you see, why is velocity changing? See, if the speed was not, if the, you see this, so this is your, so here it is, yeah, 16. Why is, I'll tell you why the direction is changing, okay? What was the direction initially? The direction initially was this, right? You see, I component is changing, J component is changing, K component is changing.
So that's a totally different.
Right. So it's a total different direction, right? Do you understand why the velocity, why the direction is changing? Here the direction is not changing. So here when we say direction is changing, the I, J, K components are changing. Coefficients are changing. Got it?
Okay.
So here it is just the, so if you take the direction, you are interested in what is the magnitude of change. And here you are interested in what is the magnitude of change in position. So this is something you have to understand. Yes,
So
Kim.
derivative of vector R and vector B are the same.
Derivative of vector.
Of vector R
Mm-hmm.
and the one under that, they're the same.
Right, this is the same. Derivative of, what is derivative of position? D or dt of position? Velocity. I just use v instead of this thing. So velocity, when you take derivative of velocity, position, it is velocity. When you take derivative of velocity, you are going to get acceleration.
So both these answers the same?
Right.
So both the answers are the same?
No, that is the whole point. It is not the same. It will be different. So how do you do this?
You see the same thing?
Huh?
If
One is
d over dt times r,
Hmm.
and then you have the same thing over here.
No. Where is the underline? Underline is missing, right?
Yeah.
So that underline is very important. So how do you see? How do you take the derivative of this?
You take away the components.
Huh?
You take away all the components, right?
No, it is just that, see, this is what you have 8t square plus 7t plus 6 cube plus 5t cube plus 4 square plus 0.3t4. I'll show you why it is not different. The whole raised to half, right?
how's that?
Huh?
How's that first person?
8.
No,
The
right.
cube,
Huh?
Cube.
Where is cube?
On the iPhone,
8t squared, you have that whole thing in,
Oh,
cube.
yeah, sorry. And a square.
And then the 2t cube is actually 2t squared.
5t cube plus 4
Yeah, 2t squared. That's the line.
square. Okay.
and that's one.
Is it better? Alright, how do you make the derivative of this? You have half into 8t square plus 7t plus 6 square plus so on raised to minus half.
So the magnitude is
Into 2 8t square plus 7t plus 6 plus 2 5t cube plus 4 plus 2 into 0.3 t to the power of 4 plus 2t square plus 1. Okay? Into you understand what I'm doing? It's a function of a function of a function here. Right? So now you have to take a derivative of this. It will be 16 t plus 7 plus 15t plus 15t square 1.2t 2 plus 4. You understand what I did? How do you take the derivative of this? The derivative of this is the whole raised to, so you have to consider this as a function. Whatever is in the square parenthesis or square brackets. It will be half. Huh?
Okay, so you subtracted it and brought it out in front. You did the derivative of that.
I took the derivative of something in a square bracket. So this is the whole function. Right? Then each of these in the parentheses are functions. So you do function, so 2 into that function plus 2 into that function plus 2 into that function. Each of these is a function. So you do 16t plus 7 plus, this is just, this is something you should know. Power? This is not the product rule. This is implicit functions. Chain rule. Right. So if you have d over dt of f of g of h of t. Running out of brackets. So if you have it like this, right? So this h of t, how do you take the derivative of this? This would be f prime of its function into g prime into h prime. You need to do this, right? That's how you take the derivative. That's the chain rule. So this is the chain rule. Now, if you once you have this, what do? You can just substitute t equal to 10 and figure out the answer. So your r dot comes out to be 1935.5. Huh?
So what happened to the one half that we put in front?
What? Which one? This one?
Yeah, the street.
When you get the derivative of the square root.
Yeah.
So all is just one expression.
This whole thing is one expression.
I have a question. So on this second line in that circle you just did, you did the derivative of 8t squared, right?
Mm-hmm.
And then where did the 2 go? So you can multiply.
Now first I need this one, right? This one you're talking about?
No, go up one line.
Huh?
Up
This
one,
one.
yeah, right there. You said 8t squared. You
Uh-huh.
got the derivative of 16t, right?
16, this is 17, right?
No, I'm saying you went down the line to
Right.
16.
16t. That is 2 into 8 is 16t.
T. So where did the 2? You didn't multiply the 2 in front of it.
2 is just this thing.
2?
2 is just, it is a coefficient. See, it's something like this. Here, pay attention, everyone. I'll just take one of the terms and demonstrate, okay? If you really want it. So if we had to take the derivative of, let's say, very simply 5t cube plus 4 square, this whole raised to half. So how do you do this? You do a half into 5t cube plus 4. You keep the square as it is. This is half minus 1, right? It is minus half. Not dot, but multiplied by, you take this bracket now.
Oh, yeah, okay.
You do 2, 5, t cube plus 4. You take the bracket, again 2 minus 1 is 1. Multiplied by, you take the 1 in the parentheses. It's just 15 t squared. You got it? That's the reason we don't see a 2. That 2 is gone. So that's what is here. 15. So here you have 15 t squared. So you can think about, so this component is missing here, but you can think about this as this. And this as this. And this as. You have to do it for all the components. And then you substitute t equal to 10. Get it? Brandon?
I'm gonna go back through these notes and I'll get back to this. I get up to that point. Circle, I get up.
Yeah. It's just an implicit function. Just look up implicit functions. How to take derivatives of implicit functions. Yeah, or chain rule as he pointed out. Look up chain rule. Chain rule. This is all chain rule. Okay. And this is a big chain rule. Okay. Alright, we can stop here. See, as I have told you,